I need to take all my coolant fittings that are meant to be blocking off things and take those, drill them out, thread them so I can put in this barb. There's another one I have for a -6. That's for the coolant lines for the turbo. This one's going to be coolant lines for the wastegate. So I'll machine them out, tap them, and then put these in there. This is the point where it just before it threw it out. So it actually threw it out at 59.70. I'm going to take this point and put it at the number that should be to make the 0 point in the middle. So this should be 0. And then over here should be either negative or positive, and over here should be either negative or positive. I'm just going to guess that this is negative. I can't really remember. So the edge of this should be either a negative, positive of this number at this side, and a negative or positive number of that at this side. So there would equal center. So I select the axis, and then I just put in what I want it to be. 2.99123 number, and set. Now we can go over and check our work. The edge of that should be this, over here. So we'll check that over. So here's where I messed up. I forgot to compensate that this is 200 thousandths. So it was actually over. So technically, I should have taken the length of this, added 200 thousandths to that number, and then divide that by 2, and that's what the edges should be. So now let me correct my math, and then I'll just redo that offset. I took that original number, added 200 thousandths to it, came out with 6.1985, divided that by 2 is 3.09925. So I need to round that down or up. And then now I can enter that information because I'm right at the edge of that, because I already used the edge finder to find the edge. And I'm going to select the x-axis while we're in digital readout. And we're going to enter 3.099. Could put 25, but it's probably going to round that up. So it just rounds it for you. Now that has found our 0 point. Oh wait, was that supposed to be a negative number? I think that was supposed to be a negative number. Okay, so let's just take the X. I wonder if that will set it like that. No, never mind. Let's do this. 3.09925. Negative value, set. Now that has found our 0 point, so I'll go back through and check it over just to make sure it's right. So I'm getting this number, 75 is throwing it out. So I want to split the difference. This is where we're at. We're at 3.0990 on this side and 3.0980 on this point. So I need to take this one. I basically need to find the difference between the two. So this one is 1,000th over this way. Well, there's basically 1,000th difference between the two. So it's supposed to be 3.0985 and 3.0985, but a negative number on that side. So I'll change this now that I have this side. And this is going to be a positive number, 3.0985, and we're just altering that number. So now the other side will be a negative value of that same number. It's hard to get that half thousandths. That's as close as that's going to get. So I'm going to check the back of each of these. So what I did was I measured this diameter, or not diameter, I measured this distance. So that distance was 2.146, that's in inches, plus 200 thousandths for edge finder. And then we got 2.346, and I divided that by 2, which gave us 1.173. So this point, I think, is going to be the positive number. This is going to be a negative, I think. Edge of that, we need to put in 1.173. And this is where that location was, so negative 2 thousandths. So we're going to change that 1.173. And that's a positive number. Okay, we got that in. We're going to pull it up. Over on this edge, we should get a negative. That should be the edge of this side. Let's check it. So it's throwing it out at negative 1.1735. So the true value that I'm measuring here is 1.1740. So this really needs to be, that when it's at that location, it needs to be negative 1.17335. We need to make a cut in our jaws so we can grab our part that we're going to machine, which is this piece. So we got 565, the diameter of this, so that's the size. We need to cut the jaws too, so that we can compress the part properly to hold it. So I need a reference point. So what you do is you select the Z-axis and then you hit the absolute set to zero that out when it's at the position you want. So I already did that. Now I'm ready to write the program. So everything is in the zero position. It really doesn't matter if I throw this out of the zero position because it already knows where the zero is. I'm doing this in 2-axis, so the Z doesn't have any reference. The reference for the Z is just for me. It's so I can measure how deep I want this cut to be. Now we're gonna write this program, so we're gonna go back, program, begin, let's do a profile. And we'll do a circular profile. We're going to use our 0 points that we entered. The radius, so it wants to know what the diameter we're going to cut to. And it wants that information as in a radius. So we need to take our diameter and divide that by 2. And then enter that information as a radius. So that's what I got for the radius was, that number 0.565 divided by 2 is 0.2825. Direction 2, because set for counterclockwise, that's number 2. So enter that. Offset. So it's basically saying, do I want to cut left of diameter, right of diameter, center of diameter? So I want to cut to the left because we're cutting an inside bore. If we were doing an outside cut, we were going to cut on the right too. Finish cut, I don't care about that. Feed rate, 10. Well, probably not, 4. Tool number 1. We gotta go back to our tool table. And I actually can copy this, so I can do multiple passes. So if I want to copy that, I want to go to more, copy, repeat. First event was number 1, and last event is also number 1. And the offset, we're using the same offset as last time. We have to press the incremental set instead of the absolute set to enter those 0 points. Repeats, let's do 5. And feed 100% of last time. And the tool number 1. So now we have 6 programs, and we need to go to our tool table to tell it what size our tool is. Setup, tool table. Oh. We're using a 1/4 inch end mill. A 1/4 inch is 0.25. So now that we know, it knows what the tool diameter is, this program can be run. So if we want to go to the program, go to mode, run, start, press go to begin. They want you to load the tool in, turn on the spindle. Oh, we're in low speed right now, so we need to flip it over to high speed. It's not quite in there, so I gotta take the spindle, move it. That's in high speed. Now we're gonna go off our high speed measurements. So you need to set what you want that to cut. So you can look up the information online. I have a 4-flute bit. I'll just turn it on. So you gotta turn on the motor so you can change the speed here. So don't change the speed unless the motor's on. I'll figure out what the speed is, I'll set it, and then we'll make that cut. Check Z, so I would lift it up if I thought that there was going to be an interference, but there isn't going to be one. So we're going to run it. Bring it down to like 200. These pieces I used as shims so I could tighten the chuck without compressing it all the way. So I'm just going to clean all that up, and then I can put my part down in there and start cutting my part. So what I'm doing is I'm taking these, drilling them out and threading them so I could use these coolant ports. Here's one that I've already done. Here's actually two that I've already done. So the original process that I did is I wrote a program to cut this out to 339 thousandths all the way down to about 50 thousandths above the start of the O-ring, so it's a little thicker down here because it's got that cut there. So this is going to be 339 inside diameter, and the depth from here to here is going to be 450 thousandths. Then from that 450 down, I cut it out to 295 thousandths on the inside diameter to give it a little bit more thickness around that O-ring. So I need to cut this one, so I'll show you what that looks like. You know, we originally got our 0 point where I cut the chuck, so I never changed any of that information. And here's my programs that I wrote. So 0, 0, that's my center. You know, I'm not doing an off, like putting the hole in an offset location or anything, just the original center. The diameter, or the radius, so the diameter I needed is 339 thousandths. So I divided by 2, you get 1695 for the radius information. I'm gonna go, the bit is going to go in counterclockwise direction, so it's going to go like this. You could do clockwise if you wanted to, but from what I've seen, you always go that way. Tool offset is to the left because we're cutting out the inside diameter. And finish cut, I don't put anything for that. Feed rate for tool number 2, because in the tool table, I put in a 3/16 bit. So if we go back to the tool table, setup, tool table, tool number 2 is 187 half a thousand. Okay, so that's the tool that I have in there. It's a 3/16 bit, which is this dimension. Now I just need to go run my program, so I'm going to go to mode, run, start, press go to begin. It's telling me to load the tool. So the tool's already loaded, and it says to start the spindle. So I'm going to flip the spindle on. I've got my RPM set at 1800. Press the go. Set my Z. I want to start my cut. But before I do that, I'm going to touch down here and record a Z location. So I'm touching the part, and I put in set Z to 0. Need to know how to do that. You click the Z button, and then you can just put absolute set to turn it to 0. We can go back and run our program. Run, start, go, spindle on. Press go again. It's telling me to set the Z. So now I'm going to bring it down and make our first cut. Set Z. Ready for our next cut. We got about 1500 here. So I'll keep doing this until I get to 450. We're at 450. That's our final cut. It's a good idea to first put the fitting in and oil up the O-ring and make sure it goes all the way in before tightening the bolt. If you do it the other way shown in the video, it will tear the O-ring. But luckily I had new O-rings on hand to replace this one. I also had to sand down all the corrosion where the O-ring goes in. This car was a northern car. It was from New Jersey. So where all the O-rings went, there was a lot of corrosion before the O-ring goes in. So I had to sand all that down. Otherwise, the corrosion would rip the O-ring every time, even if I used oil. So it's wise to go ahead and clean up those areas so the O-ring goes in smoothly. Here's a look at the O-ring after I tore it because I forced the fitting in with the ratchet by tightening the bolt down. The front coolant fitting I ended up replacing with a 6AN fitting, and I completely deleted my 4ANs because I couldn't fit in the 4AN fittings with the wastegate because I was trying to run coolant to the wastegate, but I couldn't end up making that fit. The rear fitting I ended up also deleting, and then one of the middle fittings I ended up capping that off as well, and then I used another one of the middle fittings to run my other 6AN to my turbo to cool it because it's a ball bearing turbo. My ball bearing turbo uses oil and coolant, so these are all coolant fittings that I have drilled and tapped. Here's a perfect illustration of how to put the fittings in before tightening the bolts down. It's important to sand the corrosion off of the bevel where the O-ring goes in and oil up the O-ring real good, then push in the fitting, which will prevent the O-ring from tearing on installation. Here's a demonstration of how I removed the corrosion so the O-ring would slide in properly without tearing. So I put a 90-degree fitting for a 6AN to a 1/8 pipe thread in that one to give me a little bit more clearance against the wastegate pipe. Recirculated. And then this one I should have just left alone since I plugged it off, but I don't think I'll have a clearance problem. I just have to put everything together and check it. Here's our oil feed line that was included in the kit. This is our coolant line for the turbo. Since we're going to the ball bearing GT35R style, I'm running those both up behind the wastegate there. And now I'm ready to try and put this downpipe thing on there and see if I'll have enough clearance for my lines here.